Okay, folks, this is our Unit 2/3 test review. So we have talked a lot about how to generate slope of lines, right? So you're just going to find 2 points that are on the line and on the grid, like on a corner of the grid. So I've got this one here at 0, -3, and I got this one here at 5, 0. Add a little bit of color to this. So I got these 2 points right here. I basically want to figure out the rise and the run, basically how far up and how far over the points are from each other. So I start here, I just count up to this line. I go 1, 2, 3. We call that our rise. And then I go from here 1, 2, 3, 4, 5. That is our run. Now we're going to put these together as a fraction. Our variable that we use for slope is m. Right, we'll call it rise over run. That's how we organize our fraction. In Miss Ryan-Fleisch's class next year, you'll see it as delta x over delta y. It just means the change in y divided by the change in x, or your vertical change divided by your horizontal change. So if I take my rise of 3 and my run of 5 and I put them together into a fraction, that is the slope of this line. Basically how steep it is positive, it's going up 3 and right 5. Okay? Now, as we move here, I got these two triangles. I have DEF and I have triangle HIJ. We can see that this student is saying that HJ is 6 inches longer than DF. So I have HJ, I have DF. The student claims that he can add 6 inches to 5 to get the length of HI over here, basically taking this side and matching it to that side. I'm going to match up sides here with a little bit of color. We'll put pink right here. And, oh, I might have a green one. This yellow one is losing potency there. And then I'm going to match this one here to this one here. Okay, so now we can clearly see which side matches to which side on the kind of respective triangles here. But why is this student incorrect? Well, when we're doing dilations, we don't add to find the new triangle, right? We multiply, right? So we take this triangle and multiply it by the scale factor to get this triangle, or the reverse, right? So why is the student incorrect? When dilating, let's make this official. We'd say the student is incorrect. Because when dilating, we multiply rather than add. Sorry about the noise right there. Okay, so boom. First checkpoint right there. If you can organize your answer just like the question is organized, you will do better on the test. Explain the correct steps needed to determine the length of side HI. Let me do the math first, and then we'll kind of work backwards to explain the steps. So we've got to figure out the scale factor, basically then how much bigger or smaller one side is. I'm going to assume that this is an enlargement, so we're going from the small shape to the big shape. How we do that is we take a side from the big shape, and then we match it up to a side from the smaller shape, and then we divide. So we'll take 10 divided by 4. This is a calculator test, so 10 divided by 4 is 2.5. So our scale factor, which is k, right, that's the variable we use, scale factor is 2.5. Now, if we want to find this side right here, what we do is we take this 5, we're going to multiply it by that scale factor of 2.5, and we'll get whatever we get when we put it in the calculator. It's going to be 12.5, but let's just double check. Oh, look at that. So 12.5 inches right there. And so we actually get, this actually gives us the answer to the next two. We just got to explain it. Since it says explaining, we do have to write it in sentences. We can't just show the work like we did right here. So we find the scale factor. I actually like how I said this in my last class. We divide side HJ which is 10 inches, by side DF, which is 4 inches, to get our scale factor of 2.5. Which we then multiply side DE by scale factor 2.5 to get 12.5 inches. Boom. Check mark there, we're good. What is the length of HI? We can just say that HI is equal to 12.5. That's what we got. And then give the length of FE, so the green one right here. So it is missing a length here, so we've got to use this information to get it. Since we're starting with the bigger side, we're going to divide by the scale factor. So 5 divided by 2.5 is 2, right? So we'll just show the work right here. 5 divided by, this is going to give us FE. 2.5 is 2. How did you know that, Mr. Wishart? Oh, because I've done this like 4 times today. Also, I have a calculator. 5 divided by 2.5 is 2. So FE is 2 inches. Okay. If you struggle with those calculations, please use a calculator. A figure has been transformed, or a figure was transformed to create a congruent copy of itself. Which of the 4 transformations could it have been? Explain your reasoning. So the important word here is congruent. Okay. Congruent just means same size, same shape. Basically, the angles of each figure are the same, and the side lengths of each figure are the same. So, but we can simplify that to say same size and same shape. So we have 4 transformations. We've got translation, reflection, rotation, and dilation. Now, translation makes congruent figures, right? Reflection also makes, sorry, let me finish that off, makes congruent figures. We could talk about this more in depth, but we did so much practice with this that we should have this in our toolbox, no problem. Now, we call these 3 types of transformations rigid transformations. That just means that when you do them, they do not change the size or the shape. They maintain the size and the shape. But when we get to dilation, this does not make congruent figures. And the reason is because it changes the size. They either get bigger or smaller. Changes size, they are similar rather than congruent. Rather than, that's a lot. Golly, pause it if you want to. Okay, we got 2 different factories producing drones. Information about these 2 factories is presented below. So in Denver, we have a factory that makes 140 drones every 40 minutes. And then Detroit, we have our X and Y axis on the graph. So I'm just going to kind of like make those a little more bold. In Detroit, we have this representing Detroit. So we're going to write an equation that models the function between X, the number of minutes, and Y, the number of drones at the Denver factory. So that's our X, that's our Y. When we figure out the rate, that's basically the unit rate. That's the slope of this graph. It's the slope of this line. So that's our Y value divided by our X value. So it's 140 divided by 40. It's going to give us 3.5. Again, just use a calculator. It speeds things up on a test. Okay, gives us 3.5. We put it together in an equation. That's y equals 3.5x. Because again, that is our basic form of the equation at this point for a proportional relationship. So y equals 3.5x. Explain the steps you took to create your equation. I divided the number of drones made, which is 140, by the minutes, or by the time, 40 minutes, to get 3.5, which is the slope, or the unit rate, kind of either way, And then I plugged 3.5 into y equals mx to get y equals 3.5x. Oh man, that's brutal. Okay, write an equation of the models. The function between x, the number of drones. Gosh, this isn't even labeled. Wow, that's terrible. And y, the number of drones made at the factories. This is time in minutes. And then this is number of drones made. Okay, so when it's a proportional relationship, always start at 0, 0, right? Because then you can kind of just go up and be like, well, I don't want to make a point there. I don't want to make a point there. Oh, look at that. That's on the corner of the grid, and it's on the line. So then we're going to figure out the rise over run. We did this on the very first question on this review, right? And it may look like we're going up 3 boxes, but each box is worth 20. So we're actually going up 60 for our rise. We're going over 1 box, but that's actually 20 right there. I know this is not the best graph. We're going to divide them to get 3, which is y equals 3x. So Detroit makes drones at a rate of 3 per minute, basically. And Denver makes them at a rate of 3.5 per minute. So Denver makes them faster. State which factory this is and how you determine your answer. So we'll say Denver makes drones faster. Because their unit rate, or the factory's unit rate of 3.5 is higher than the Detroit unit rate, or the factory Detroit's unit rate of 3. Drones per minute. Whew. So much writing. Okay, I'm going to sharpen my pencil and we'll move on. Okay. Number 5, which ratio correctly models the slope of the line? Well, we've done a lot of work like this. Normally they're numbers. Now they're letters, but it's still rise over run, right? So it's A over B, right? Shouldn't be too crazy there. The line was formed by the equation y equals 2/3 x. The line was then translated vertically by 2 units. Graph the line after the translation. I'm going to start with the line of y equals 2/3 x, right? There's an invisible plus 0 here if you don't have a number, which means we start at 0, 0. Then from there we go up 2 and we go right 3. Up 2, right 3. We'll reverse it to get a few more points on the line. So again, this is our original line. This is not what we need, but I think it works visually if you have both lines on there so that you can see what happens after you translate it vertically by 2 units. So we're going to take every point that we made and we're going to move it up 2. So starting here, go here, 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 goes up 2. This point goes up 2. This point goes up 2. Use a straight edge, a ruler, or a protractor to make this as straight as you can. And we have our line right there, our translated line, which, I mean, that's really all that's happening when we add a y-intercept on there. But yeah, there you go. Consider the linear function modeled by y equals negative 2/3 x plus 5. State the value of y when x has a value of 12. State only a value. This is kind of like for our test entry system. And then show or explain the steps, state the value of x, and then show or explain your steps. So, got my equation right here. I'm looking for y. I'm just going to kind of like put all my work right here. So, I have a value, and x has a value of 12. What I'm going to do is I'm going to take that 12 and put it in for that x. So, it's going to be y equals negative 2/3 times 12 plus 5. Now, this is going to be 24 divided by 3 is negative 8 plus 5, which is a y value of negative 3. Okay, You could use the calculator. You could say clear and then get that. Let's do boom. We'll do a negative 2 divided by 3. And then we will multiply by 12. And we end up with a negative 8. Look at that. Okay. So now, when it says show your work, makes it super easy. We just did it. Now, when we're looking for the value of x, when y has a value of negative 3, we're going to replace this y value with that negative 3. So negative 3 equals negative 2/3 x plus 5. We subtract 8 to here. It's our inverse operation. We get negative 8 equals negative 2/3 x. Now we're going to divide by negative 2/3 x, which is basically multiplying this by negative 3/2. Yeah. Or, yeah, I don't know. You could look at it as negative 2x over 3, multiply by 3, divide by 2. But yeah, let's actually do that. Let's do it over here just so we have more room. Negative, and I'm going to put that negative 2/3 on the left. I'm going to say negative 2x over 3 equals negative 8. I'm going to multiply. I'll just get rid of that negative first. That goes away. So I'm left with 2x equals 24. I divide by 2, and I get x equals 12. So x equals 12 is our answer, and then we have done the work already. Now, if you want to use the calculator for this, you can just say negative 8 divided by, basically reversing what we just did, negative 2 divided by 3 in parentheses, and you get 12. Look at that. Oh, and if you want to do something like this, that negative 3 minus 5, use this button here. That puts a negative on there. Negative 3 minus 5 gets you negative 8. So there you go. We got those 4. I guess when it says state only a value, this should just technically be negative 3, but what are you going to do? A bike rental company charges an initial deposit of $7 for a bike, an additional $3 per hour. How would you make a graph that models the function between time on the bike in hours and cost in dollars? I don't know, it's just kind of like go that right here, right? So the deposit, that's going to be our starting point. That's our y-axis, and this is our rate of change right there. So if I put our equation together, it's going to be y equals 3x plus 7. So I'm going to start at 7. So I'd go 1, 2, 3, 4, 5, 6, 7, roughly. And then this is technically 3 over 1, so I would go up 1, 2, 3, and then over 1. So like so. This is, again, a very basic version of this. Label my graph, time on the bike in hours versus cost in dollars. So this is cost here in dollars, and this is time in hours. If you wanted to use graph paper, you could do graph paper, but that's just a basic version of a graph without graph paper. Figure ABC was dilated to produce triangle A prime, B prime, C prime. Are the pre-image and the image similar or congruent? Explain your reasoning. Well, this goes back to what we talked about right here. Translation, reflection, and rotation make congruent figures, not similar figures. The only one that makes similar figures is dilation. And so if they're dilated, they're going to produce similar figures. The figures are similar. I'll explain your reasoning. They were dilated, which changes the size. Oh, wow. They were dilated, which changes the size. Making them similar, not congruent. All right, 10. Transform this by reflecting it over the x-axis to form triangle x prime, y prime, z prime. x-axis is the horizontal axis here. So to reflect something, you count how close each point is to the line of reflection and then duplicate that distance on the other side. X is 1 away, so x prime will be 1 away. Let's label it x prime. Z is 1, 2, 3, 4, 5, 6 away, so it's going to be 6 on the other side. Z prime. And then y is 4 away. 1, 2, 3, 4. So it'll be 1, 2, 3, 4 on the other side right there. There you go. Write an equation that models this relationship. Well, the equation is going to be in the form of y equals mx plus b. I don't know, it doesn't really matter which one you start with. Our b value is right here at 4. Okay, well, that's our y-intercept. And then let's figure out another point to put on the line. That's it right there. Then we'll figure out our rise and our run. Okay, we're going down 1, 2, 3. So since we're going down, it'll be negative. We're going right 1, 2, 3, 4, 5. Oh, isn't that the same slope we had earlier? So our slope for this is negative 3/5. We put it in the equation. It's going to be y equals 3/5 x plus 4. Sorry. The equation 1.2 x plus 6.2 models the price of a pizza. Y represents the cost of the pizza, and x represents the price per topping. So that's our slope. What can you say about the slope in this equation? Well, let's define the b and the x, right? So this is our base equation, right? Our m value is 1.2, and our b value is 6.2. This is basically how much it costs for the pizza. This is the base cost of your pizza. And then our m value is how much it is per topping. So now that we have kind of talked about that, I think I've actually answered the equation, or answered the question. What can you say about the slope? The slope of 1.2 is the price per topping. So basically each topping is $1.20. 22 minutes, guys. That was a long one. Woof.